All right, this is Algebra 2, our last lesson of the calendar year, not the school year, of course, because we still are halfway. You have double the amount of work that we're doing before you finish Algebra 2. Yeah, 6-7, solving harder exponential equations. Just as a, no, never mind, I was gonna say something wrong. Today's date is Thursday, December 10th, 12/10, come on, work, there you go, 2020, getting a bit of lag there. Our objective today, rapid fire, is to, Wyatt?
Solve difficult exponential equations using the rules of exponents.
There it is. So yesterday, 6S6 was solving your basic simple exponential equations. Today's the harder one. So we're doing like many more steps typically. So I'm looking at example 1. Again, we just have example 1, 2, and 3, and we're done. Example 1, yeah, that looks kind of hard. But you guys know what to do. It's the same steps over and over. There's just more of them now. Charles, what do we do first?
Well, first you would make the bases something simpler. So the first one you can do as 3 to the power of 3, I believe.
Yep.
And then to the power of 4x minus 7.
Perfect. What about that right-hand side?
The right-hand side, 81, that would be 3 to the power of 4 to the power of 2x plus 3.
A beautiful first step. There it is. And again, you have to have that list that I talked about. What was it? 6-1, whatever that list forever ago. Memorize those higher degree powers. So let me actually see if I can find that really quickly. What's the list? I said it was 6-1. Is that right? Nope. It was 6-2. Nope. 3. Yes. So this one, you have to have these powers over here memorized because it helps you with these problems. Okay. So Charles did the first step. Next step, I need to use properties of exponents to boil these down. Wyatt?
So you can multiply the exponents on both of those, and so you kind of like distribute it. So your next equation would be 3 to the power of 12x minus 21. That is equal to 3 to the power of 8x plus 12.
There it is. Okay. And only half the class has their cameras on, and only 5 students I can see their faces. So one person is pointing at the ceiling fan. Please have your cameras on and pointed at your actual face. Thank you. Thank you, Jade. All right, what do we do from here? And I'm not going to call on Charles nor Wyatt. Yeah, Jose.
You put together the exponents, right?
Put together the exponents. What do you mean by that?
Would it just be the 12x minus 21 equals 8x plus 12, right?
It is. Yeah. Why are we allowed to do that?
Because you have to find the x, right?
I mean, we are trying to find the x, but because the bases are the same,
Oh, yeah, the
in order for this equal to sign to be held, the only thing that's left over to make sure that we're equal to, since the bases are already equal to, is the powers need to be equal to each other. So that's what you're saying down here. Set the powers equal to each other. That's the only way to make that work. And once we hit our next unit in January, you'll realize what we're really doing. We're really exponentiating both sides, but you haven't learned to exponentiate. So now we have turned this back into an Algebra 1 problem, which this looks almost exactly what I'm putting on their final for like one of their problem number 2 or something. How do we solve this? Someone else, someone that hasn't spoken yet today. Andres.
You can subtract 8x to 12x.
Yep, and then what is our new equation after we do that?
It would be 4x minus 21 equals 12.
12, perfect. And I'll say minus 4 or minus 8x. Both sides. This is another way of showing your work that I've never really used before, but I want to try it. And then next step.
Wait, do you want me to do the next step?
Oh no, I'll call on someone else.
Oh.
Also, that's okay. trying to get more people in. Yeah, Jade.
Add 21 to both sides, so you'd be left with 4x equals 33.
I agree. Yep, we're gonna do plus 21, 4x is equal to 23. What, why did I write 48? I don't know. 4x is equal to 23. And from there, why am I, yeah, if you caught it, raise your hand if you catch there. I had 23 written here. Those people that caught it, log it. What should it be, Charles?
33.
33. I don't know why I keep writing the wrong thing. Yes, and then finally, last step, someone else. Come on, easy peasy. Thank you, Sergio, go for it.
You divide 4 by both sides.
You do indeed, and you get what?
33 over 4. Well, it's like 8 point something, 8.25.
8.25, yeah, 8.25 exactly. And in Khan Academy, just leave it as a fraction. Make it nice and easy for yourself. 33 over 4, done. Nice, nice. And let's try example number 2. Before I do that though, how well did you understand example number 1? Fists of 5. Everyone has their cameras on. Josie, Jessica. Fists of 5. 5, 5, 5, 4, 5, 5, 4, 4. Josie's at oh wait, there's a chat thing that I'm not reading. A 1 from Andres. What? Okay, Josie says a 4. Example number 2. Andres, do you have a question?
Oh, no.
Okay, Jay, do you have a question? All right, so example number 2. Again, it's going to be the same procedure every single time, just like 6-6, our previous lesson yesterday on Wednesday. You need to get the same base on both sides. Obviously, 1/25th is the base on the left, and 1/125th is the base on the right. Those are not the same base. Get the same base, and then once you have the same base, set their exponents equal to each other, then solve. What do we do to get the same base? And this is kind of the hardest bit, so I want to give the most time here to think. I already see 2 hands. I see White's hand. I see Charles' hand. Give time to think, though. How do we do this? Ooh, a new hand. Yes, Fernando.
You're gonna multiply 25 by 6. Or no, by 5, I mean, by 5.
By 5, yeah. So 5 times 25 is indeed 125. But if I multiply that bottom by 5, I also have to multiply the top by 5 to multiply by 1. And the problem with doing that is I'm not allowed to, because there's this power of 3 minus x. If I somehow had that to the power of 3 minus x as well, that would work. But now we don't know if we did that, is that legal? We still wouldn't be able to multiply. There's actually not a good way to multiply into this equation. I think our best strategy here is just to rewrite this in terms of higher degree powers. So is there any way, Fernando, that you're able to maybe write both of these in an easier way? Instead of trying to get them both to 1/125, maybe we can write them as 5 to some power with maybe a negative because they're flipped.
Would you do like 5 to the second power for 25?
Yeah, so we'll say 1/5 to the second power. And what about over here? That would be 1/5 to the
To the third power.
there it is, 5 to the third power. And we rewrite, yes, this is 3 minus x, and then this is the power of 2x plus 5. Very nice. All right. Next, they're the same base almost. There's just this weird fraction thing happening here. Is there a way to get rid of these fractions using rules of exponents? Jose?
Would you make the power like negative, right?
Negative, yeah. So 5 to the negative 2, and that's all to the power of 3 minus x. This is 5 to the negative 3 to the power of 2x plus 5. Nice. Now what do we do? I want to call him White because I feel bad. He's been raising his hand every time, but he did this exact step in the last problem. I'll call on him next. I'm going to give it to Andres.
So you could multiply the exponents for both of them. So it would be 5 to the power of negative 6 and then minus 2x.
Ooh, careful there.
Oh wait, no. Positive 2x plus
Positive
2x.
2x. Good.
Okay,
And
and
I'm
then
forgetting my equal to signs. Oops.
equal to 5 to the power of negative 6x plus negative 15
I'll just say minus
or
15. if that's okay.
negative negative 15.
Whew, there it is. All right. So just distributing our powers. Again, when I have a power to a power, that means I'm multiplying their exponents. All right, I did promise Wyatt, you're up.
Okay, so now that we have common bases, we can set the exponents equal to each other. So we can finally solve for x.
There it is, yeah. So we'll set them equal to each other. I have that negative 6 plus 2x. That was the power on the left. Power on the right is negative 6x minus 15. Thank you. Set them equal to each other, and we solve.
Mr. Sindel,
Yes.
Jess is saying she's having Wi-Fi problems.
Okay. Is it possible to still do thumbs up or thumbs down, Jess? Or is it not even working like that? She's like clicking on participants, trying to find, how do I do the thumbs up again? It's participants, and then it's like the nonverbal feedback. I can't show it because Zoom itself doesn't show up on my window.
Wait, I don't think she's in our meeting though.
Oh, she isn't?
No.
Who's this random square person? Oh, that's Cohen.
That's
Cohen's
Cohen.
here. Welcome, Cohen. All right. From here, Cohen, yeah, perfect. What do we do from here, Cohen?
Subtract 6 or add 6 from both sides.
What is our new equation after we add 6 to both sides?
2x equals negative 6x minus 9.
Ooh, careful. So if I already have negative 15, I go even lower by another 6.
Just be negative 21.
21. There it is. Yeah, nice. And I ran out of room, so let's go back up here. All right. Next step. Who have I not heard from today? I want to get everyone in. Yeah, Sergio.
I think there's a mistake, but I'm not sure.
Oh, yeah. What's the mistake?
Isn't it plus 6 on both sides? Because
So Cohen was right, and I told him the wrong thing. Cohen, I'm sorry. Thank you, Sergio, for catching my terrible mistake. Yeah, we're adding 6 on both sides. We weren't subtracting 6. So Cohen, you're right. It was negative 9. Sorry. Well, Sergio, since I have you on the line, what do we do next?
you do plus 6 on both sides.
Yeah, plus 6x, and then what do I get on both sides then?
Then you get 8x equals minus 9.
Minus 9. And let's call him Josie, because I haven't heard from her either. Oh, she just left though. Dang it. Andres. Oh. Yep.
And then you could do a x over, or no. X equals, don't you divide 8 negative 9 over 8x, right?
Yep, negative 9 over, not 8x, just the 8, right? We divide both sides
Oh
by 8.
yeah. Okay, yeah. And
Cool.
you would leave it like that because
Yeah, that's fine. Khan Academy likes negative 9/8.
Okay.
Khan Academy is a big fan of fractions. All right. Well, I had that tiny mistake that I forced Cohen into, for example, 2. But aside from that, how well do we understand example number 2, fist of 5? 5, 5, 5, 5, 4. I'm waiting on Fernando, Jenny, and Cohen. 4, 4, and I don't see anything in the chat. Cohen, where are you? I'm guessing that you guys can't see the chat right here. This window is probably invisible to you guys, right?
Yeah.
Nod,
Mhm.
yeah.
It is, yeah.
All right.
I mean,
Example
I could
number
put
3.
my chat there.
Solve the exponential equation for x. All right. Our hardest one yet, the most number of steps. So the first step is always the hardest. Well, typically the hardest. It is in this case too. What do? I see Charles and Wyatt have their hand raised just like in the last few problems. They're first to go. Anyone else know? Jose knows what to do. Anyone else? We want to get a common base, but I don't know what that common base should be. Okay, Wyatt, go for it.
Okay, so you would have been able to use the common base of 4 if it wasn't for 32. So we're going to have to use the common base of 2. So on the top of the numerator, we're going to have 2 to the power of 5 to the power of 3 minus 2x. On the denominator, we're going to have 2 to the power of 2 to the power of negative 6x plus 2. And on the other side, we're going to have 2 to the power of 4 to the power of 3x plus 1.
Thank you. All right. Now what? What are we doing next? Jose?
So we're gonna multiply the,
Perfect.
this is the 5, so it'd be 15 minus 10x.
What about the denominator?
And then it'll be 2 to the power of 12x plus 4.
And on the right-hand side?
Or equals 12x plus 4.
Nice. All right. I think we're so far so good. What are we doing next? Charles?
On the left side, you would need to subtract the powers.
I agree. Yeah. Whenever we are dividing the bases, we should really be doing subtraction with these powers. And what is that?
You'd subtract 10x and 12x. The 12 should switch its sign, so it would be 2x plus 11.
There it is. Right-hand side can't be simplified. So
Not yet.
12x plus 4. And then I'll just write as a note, what did we do? Subtract the powers. I know that I'm going to run out of room, so I'm going to preemptively say, okay, let's come back up here. What do we do next? I feel like Cohen and Jenny got some kind of lower level questions. So this is kind of the higher level. What is the procedurally, what do we do? Our new procedure, not our Algebra 1 procedure, but our Algebra 2 procedure. Either Cohen or Jenny. What are we doing for here? Is Jenny even here anymore? I don't think she is. So it has to be Cohen. Man, people are just dropping like flies. Cohen, go for it. For some reason we can't hear you. I know that you're unmuted. It must be, is your like thing down or? Still nothing. Okay, I'll call on someone else. Jade, I've only heard from you once. Do a second one.
So because the powers are the same, you're just going to rewrite their exponents to 2x plus 11 and 12x plus 4.
There it is.
You're going to subtract 2x from both sides, leaving you with 11 equals 10x plus 4. You're going to subtract 4 from both sides, leaving you with 7 equals 10x, and then you're going to divide it by 10 on both sides, and then you're going to get 7/10.
Perfect. There it is. 7/10. Woo. All right. There's our notes. I guess I could just show that one page. Fist of 5 on our entire lesson, on our objective. How well can you solve difficult exponential equations using the rules of exponents? Our final lesson of the calendar year. 5, 5, 5, 5, 4, 5. Let me look at the chat. Cohen says 4. Andre says 5. All right, cool. That concludes our lesson.
Mrs. Endo.
Yeah.
So in example 3 in the green step, how do you get 2x?
Let's zoom in here. The green step.
The 2x.
2x. Oh yeah, so let me write off the work to the side. We originally had negative 10x, and then we subtracted a negative 12x. So from there, that means we're really adding 12x, and negative 10x plus 12x is 2x. Yeah, that was a hard process. There were like multiple steps that Charles did in his head. And then that's a great question. Thank you for asking me so I can write that down.
Thanks.
Yeah, you're welcome.
Oh, you haven't posted homework yet.
Let me go do that.